All right, so now we're going to move into something called trig substitutions. So what this method is going to do, it's going to help us get rid of expressions that look like this in our integral. And these integrals, I'll just warn you, are going to be long and huge because we're going to start in x's, like here. You can see we're going to start in x's. It's going to change to thetas, get really big, and then we'll be able to take the integral, and then we'll have to get back to x's again. All right, so these are the substitutions that work. If I have this expression in my integral, then this is the substitution that will work. If I have this expression in my integral, this is what will work, and this expression. So you have to have these memorized so you know which expression or which substitution to use. So let's go through all the different kinds. So here I have 9, which is a squared minus x squared. So that's a squared minus x squared, this first one here. So it's a weird substitution because I'm saying x equal. I'm not using a u equal. I'm saying x is equal to a, and a in this case is 3, sine theta. Okay, so this is first off, you got to, x is equal to 3 sine theta. So a common mistake is to forget to find the dx. So the dx is what you find when you're doing a substitution, like a u substitution, right? So go find the dx. So the derivative here, carry the 3, derivative of sine is cosine, d theta. Okay, so here's my integral that's all in x's. I want to change it to thetas. So let's take our x and substitute in for x 3 sine theta. So that turns into 9 sine squared theta. Dx gets replaced with all of this. Be careful, that's the common mistake, is to forget to put the big thing in for dx. And then the denominator here has just an x, so I'm going to put the 3 sine theta down below. So taking everything in x's and then changing it all to thetas. Okay, the reason I'm doing this is so that we can get rid of the radical. So let's look at here. If I factor out a root 9 or a 3, right? Factor out a root 9 from here. So you can think of this as root 9, 1 minus sine squared theta, right? Then 1 minus sine squared, you know, is cosine squared. That's underneath the radical. So cosine squared, and again, I'm just reiterating, the reason we're doing this substitution is to get rid of the radical. So I have cosine squared underneath the radical, and so the square root of cosine squared is cosine. Okay, and I carry everything else along that I've got. And so then this turns into, these 2 3's cancel. So I've got a 3, a cosine squared, and a sine. Okay. So next I want to think about, how am I going to do this integral? So every integral is its own fun adventure. So I'm going to think about this, and I'm going to say, you know, it sure would be nice if this sine squared was written in terms, if this cosine squared was written in terms of sines. So let's rewrite the numerator as 1 minus sine squared. And then I can split this up to be 1 over sine of theta, which is cosecant of theta, and sine squared theta over sine theta, which is sine. So I'm introducing this. I'm doing this on purpose so I can introduce you to yet another integral you need to know. Integral of cosecant is ln of cosecant minus cotangent. Okay, so from here, I get this 3, ln of cosecant theta minus cotangent theta, and then this antiderivative of this 3 is times this negative sine theta, and that gives me a positive 3 cosine theta. Whew. Okay, so that's what I get in thetas. I need to get back to x's. How am I going to get back to x's? All right, so we go back to the original substitution, and that was x is equal to 3 sine theta. So if I rewrite that as sine of theta is x over 3, you're thinking triangle, right? There's my theta, So sine of theta is opposite over hypotenuse. And what am I trying to get? I'm trying to get cosecant and cotangent off of the triangle. So I am going to need this side here. So this side here, you know, is 9 minus x squared. Oh, would you look at that? Isn't that the expression that was in my original problem? The original way long ago, it was. So that'll always happen, your third side. Just kind of double check. Okay, so remember, I have this in thetas. I need to get back to x's. So cosecant, you know, is hypotenuse over opposite. There it is. That's cosecant. Cotangent is adjacent over opposite. And then cosine is adjacent over hypotenuse. So putting in for the trig functions the x's. Now we're done. Whew, long problems, yes?